Osmosis is the movement of solvent molecules across a semipermeable membrane. Bless you. Now, in looking at this diagram of your semipermeable membrane down there, are the solvent molecules going to go back and forth, or are they going to go one direction? Well, they're going to go one direction. Solvent molecules will always move from high to low concentration. From low to high. Sorry. Solvent molecules will always move from low to high concentration. Why are they moving? They're moving to try to equal out the concentration. So if solvent molecules, I'm going to go back to my diagram, are moving this direction, they're trying to get this side to be the same concentration as this side. And I can do that if I dilute this left side. So what's going to happen as the solvent passes through that semipermeable membrane, you see that here. The level of liquid on the left side increases. The level of liquid on the right side decreases. Now, when does osmosis stop? It can stop when the two concentrations are equal. But what if they can't get equal? What if enough solvent can't pass through for these two sides to ever have equal concentration? Well, the difference between, y'all see this dotted line here and here? When osmosis stops, that is your osmotic pressure. Okay? It's a measure of the distance here. And so that's what osmosis is, and that's what osmotic pressure is. The idea of osmosis and osmotic pressure, hang on, I got another picture. This picture, I think, is in your book also on page 560. It's something very similar to this. Do y'all know what that donut-shaped looking thing is? Red blood cell. How'd y'all know that? You learned that at some point, right? That's what a red blood cell is supposed to look like. When you have an IV, and those are intravenous, they're going into your bloodstream, it's extremely important that the concentration of the saline solution or whatever is in the IV is what we would call isotonic with your blood. What does the prefix iso mean? Do y'all know? Iso means same. So an isotonic solution, it's the same concentration. And I'm going to use square brackets for that means concentration. If a solution is isotonic, it means same concentration. So if the solution is not isotonic, hang on, I went back a slide, and if you have a hypertonic solution, what does hyper mean? Huh? It's more, okay? If the solution is hypertonic, that means the solution is higher concentration than the red blood cells. So look at what's happening here to the red blood cell. If the solution is higher concentration, well then the solvent in the red blood cell is going to cross the membrane of the red blood cell because it is a semipermeable membrane, and the red blood cell is going to lose solvent. And so what's happening to it is it shrivels up, and that is called crenation. Have y'all heard that term at some point? Okay, it deals with osmosis and the concentration of the solution. What if it's a hypotonic? Hypo meaning it's less concentrated than the red blood cell. Then what's going to happen? The solvent, the red blood cell is going to absorb solvent, and it's going to start to absorb, and it's going to swell up, and it could burst. And I believe, what's that called? Is it apoptosis?
Yes.
Okay. It's apoptosis when the red blood cell would swell up and burst. So both of these situations, hypertonic and hypotonic, can be lethal.
Both of those are like a disorder too.
Are they? Like a disorder you can't control? Or doesn't it have to be brought on like with an imbalance? It's not a permanent disorder.
One's taken into effect with high blood pressure.
Is it? Is blood pressure related? The swelling and the dying of them? Or?
Just the name.
Oh, the name? Okay. I'm not sure about it. I know like there's sickle cell, which is, okay, you're thinking of sickle. That's when they're just not donut shaped. They're misshaped because of a substitution in amino acid. Yeah, sickle cell is different from this. There we go. The formula for osmotic pressure is pi. Pi is the symbol for osmotic pressure, is equal to MRT. Huh? You've heard that from? That's the formula for osmotic pressure. Where the pi symbol, y'all, that is osmotic pressure. And the units for osmotic pressure are some kind of pressure units, typically atmospheres. What does that capital M stand for? The capital M stands for molarity. What is R?
Constant.
R is that same ideal gas constant. .0821 liter atmospheres per mole Kelvin. And y'all know that for your test, I would tell you what R is. I don't expect you to memorize it. And T, of course, is temperature. Does it matter what kind of units you use for your temperature?
Yes.
Yes, it does. It's got to be in Kelvin. Don't make that mistake, because y'all know that just from reading problems, usually it's reported in Celsius, right? So just watch for that and remember to convert to Kelvin. Y'all remember, I'm sure, how to go from Celsius to Kelvin? Add 273. Okay. Let's work an osmotic pressure problem.